This isn't a model, it's a system that generates the model. In the last video, we looked at why AI modeling gets things wrong. Now let's take a look at how we can fix that. Instead of modeling this counter manually, I've defined the rules that build it. So instead of geometry, I'm working with parameters. I'm working with the width, the depth, the height of the total counter. I can also change the vertical radius on the right-hand side of the unit. I've got specific details like the countertop, its thickness, its shadow line, the recess of that, and the kickplate height and depth. I've even got a selection of materials that specifically apply to these clients' corporate identity standards. See, each of these controls are part of how the counter is constructed. For example, if I change the width to 2 meters and the vertical radius at 50 millimeters and apply that to the selected, these changes are immediately applied. The whole object updates correctly. But it's not just scaling, it understands relationship. See, the shadow line stayed consistent when I updated the top of the counter. The kickplate didn't move, neither did the body. Everything shrunk slightly to accommodate the increased height of the countertop. The same with the vertical radius. If I increase this to 200 millimeters, it will adjust both on the countertop, the shadow line, the body, and the kickplate. Each of these radiuses are connected in the construction of the object. Everything stays consistent and everything behaves properly. This isn't resizing geometry, it's rebuilding it. And this is where AI actually becomes useful, not to model the object, but to help to define the system. Let's describe the object in an AI workflow. I shall open up a ChatGPT window and I will use WhisperFlow to generate the logic and narrate to ChatGPT how that logic should behave. WhisperFlow is a very simple app. It allows you to speak and the AI generally takes your conversational language or your conversational style of talking into written format. Here we go. ChatGPT. I want to create a counter in SketchUp using Ruby script. I don't want this to be made into an extension as of yet. I simply want to copy and paste the Ruby code into SketchUp Ruby console. The counter behaves something like this. It is a 1200 millimeter wide counter that is 800 millimeter high and about 450 millimeter deep. The counter should behave in the way that we construct it. Let me describe to you the details of this counter. The counter has an 80 millimeter thick or 80 millimeter high kick plate that is 30 millimeters recessed. The body of the counter is about 600 millimeters high and the countertop is 30 millimeters thick. Below the countertop sits a shadow line. The shadow line is 10 millimeters deep and 10 millimeters high. The 10 millimeters deep that I describe is the recess of it. All the edges of the counter that are vertical should have a radius of 30 millimeters. Please build this as simple Ruby code so that we can test it in the console. Okay, I end the WhisperFlow conversation. It copies all the text as best as it understood my accent, and I'll send this prompt. It now obviously has to think and immediately ensure that it is going to create this in Ruby script, not in any other kind of coding language. And this takes about 12 seconds. I personally don't do any coding. I can understand a little bit of what is happening here, the structure of how ChatGPT is constructing this, but most of this is vibe coding. Let's copy this, move this out of the way, go to Extensions, Developer, Ruby Console, and paste this in. It now has created the counter which we asked for. Let me drag this to the side of the counter that I was showing you earlier. Just created the counter top, which measures 30 millimeters, a 10 millimeter shadow line, and an 80 millimeter high kick plate. I could select all of these groups and simply soften the edges to make this easier on the eye. This is basically the design system that we wanted to create. We have now generated the logic and tested it into SketchUp. Now let's turn it into a tool. We go back to ChatGPT and we simply ask, "Dear ChatGPT, please can you take the logic that we created here and transform this into a SketchUp extension? The Ruby script that you created earlier is working correctly and the counter has been created. The SketchUp extension should behave like a dynamic component style menu. We want to be able to change the width, the depth, the height, the radius, the kick plate height, and the shadow line height and depth. We should be able to adjust the materials. We should be able to change the geometry and be able to generate a new counter or make changes to an existing counter in the model that was previously created with our own extension." Let's write an RBZ file with a small icon that we can paste into the toolbar of SketchUp. This will be our first test. So let's call this plugin YouTube test version 1. We enter Whisper Flow, we paste the text in, and we can expect that this will take a little bit longer. I'll give you some behind the scenes working of how I created the final plugin, how I created the final tool that you see here on the left. As I described earlier, I specifically mentioned to ChatGPT to create a button to create a new counter and a button to apply to the selected counter. This was something that I only was able to create through experimentation previously. Once I created the original plugin, it was functioning, but when I closed the software and rebooted my computer the following day, for some reason the whole plugin was frozen. It had to do something with an HTML bridge back to the Ruby code. Now, as I said, in vibe coding, you are generating code through an AI, and so not being a coder myself, but rather a spatial architect, I have to rely on the AI to tell me whether the code is actually correct. So it takes some time sometimes to test some of the errors that you might come across. And the errors that you come across are easily tested. You can take a screenshot of the current conditions of your model and both the way that the plugin looks, and then feed that screenshot back into ChatGPT or any AI model, and then explain the issue at hand. All right. In about 38 seconds, the RB file was created. It needs to be installed under SketchUp, and then we can update the counter. Now, an RB file is not ideal because ideally we can, from the extension manager, install an RBZ file. So let's ask the AI to update that. Please generate a packaged extension as an RBZ file so that I can install it into SketchUp 2026 from the SketchUp extension menu, from the SketchUp extension manager. So often better to be a little bit more specific. In this case, we didn't tell it to create the RBC file, so it created an RB file, which is fine because oftentimes the RB file can actually be pasted into the Ruby console itself and doesn't have to be installed or loaded into a specific folder. The RBC file is a little bit easier because we can install it directly from the user interface of SketchUp while it's open. So let's download the RBC extension. And under my downloads, is it now called YouTube Test Counter version 1. Great. Let's go to Extensions, Manager, Install Extension, YouTube Test Counter version 1. And let's close that. Then, as you can see, it creates this image. It shows a face of someone who's knocked out. This generally indicates that it hasn't actually been able to correctly create the icon. It has tried to, but the icon is not visible. However, instead of fixing this error, let's continue on with the tested version. Okay, great. So the tested version allows us to create a new counter with a width, a depth, a height, and all the other elements. Let's create it. Okay, great. You can see the specifics of this unit are slightly different. It's not using the same materials as we have in this extended version, but reopening the tool and making some adjustments allows us to basically create this parametric modeling the same way that we normally do in SketchUp dynamic components. But again, as we defined the counter, we created our own conditions within our own idea and our own logic for this specific object to fulfill the client's needs. So you can rewrite or you can optimize these kind of extensions specific to a specific client. Now, this in the long term might get overwhelming if one would have to have multiple extensions of the same kind of object in this environment. So there certainly is optimization. But once this tool exists, we don't need the AI anymore. We can now generate as many variations as we would like to see. This isn't just about counters, I hope you see. This could be about shelves, displays, stands, anything with repeatable logic. So the more experience you have, the more powerful this becomes. In the next video, I'll show you how this becomes a full design system, not just a single tool. Here's my final thought. Stop drawing objects and start defining how they are built.